Hello and welcome to anyone tuning in to video 2 of our Functions and Equations unit for IB Math. In this video, we'll be going over 5 questions that help apply knowledge to exam-style questions. And now, without any further ado, let us begin with question 1. The first question is to show that the function f of x, which is 2x squared minus 6x plus 4.5, touches the x-axis at just one point, and also to check your answer by sketching f of x. Here we can see that we have a show that question, and so in order to show that there's one point touching the x-axis, we'll simply find the discriminant of f of x. We can see that the discriminant is 0, which tells us that there's only one value at which the function equals 0, also meaning that f of x only touches the x-axis at one point. Thus, we've shown that the function f of x only touches the x-axis at one point. By sketching the graph of f of x, we can visually confirm this at the vertex 15, 0. Moving on to question 2, we are asked to find the values of m for which the function y equals mx squared plus 5x plus m plus 12 touches the x-axis twice. This time, we need to find the range of values for m in which the function will have a positive discriminant, since it has to cross the x-axis twice. To do this, we'll first reuse our discriminant equation b squared minus 4ac to find a quadratic for m. And since we're finding the values for which the discriminant is positive, we will then set the quadratic as greater than 0 and solve. Making sure that our inequality is correct whilst rearranging the equation, we'll get two zeros for m. We can then find that the values of m for which the original function y has two x-intercepts will be between negative 25 over 2 and 1/2. This can be checked using a simple sign diagram. Question 3 is another question in which we're asked to find a value, specifically the remainder when the function f of x, 3x cubed plus 2x minus 5, is divided by the function x minus 2. Here we'll provide two methods to solve for the remainder. The first method being using long division, which is just dividing the original function f of x by the dividing function x minus 2. Doing this, we can find that the remainder will be 11. However, there are times when this method can be tedious or require meticulous calculations. And for that reason, we can also use a second method. This method will find the 0 for the function we are dividing by, which in this case is 2, to solve the function which will result in the remainder. Question 4. When px is divided by x squared plus x plus 1, the remainder is 5x plus 2. And when divided by x plus 2, the remainder is 1. Find the remainder when px is divided by x squared plus x plus 1 and x plus 2. Here, we are given two factors of px and their respective remainders to solve for the remainder when px is divided by both of the factors together. First, since we have factors and remainders given to us, we'll rewrite px as an equation using the factors and remainders. Therefore, we'll get px is equal to x squared plus x plus 1 times an unknown function qx plus 5x plus 2. And px is equal to x plus 2 times rx plus 1. By rewriting px as two different equations, we can then make a third equation with x squared plus x plus 1 times x plus 2, since that's what we're trying to factor. The function then comes out to x squared plus x plus 1 times x plus 2 plus an unknown constant a plus 5x plus 2. This comes from dividing qx by x plus 2 to allow the equation to be factorable by both of the factors. The constant a comes from the remainder of qx when it is divided by x plus 2, and we'll be solving for the value of a in the next step. We'll substitute negative 2 for x to make finding a easier, and once this is done, we'll find that a is equal to 3. By now knowing a, we can now expand our equation to the form x squared plus x plus 1 times x plus 2 plus 3x squared plus 8x plus 5. Hence, our remainder for factoring px with both of the original factors will be 3x squared plus 8x plus 5.
Finally, question 5. Find a and b, given that 15x cubed plus ax squared plus bx plus 8 has factors of 3x plus 1 and x minus 4. From the question, we know that two factors of the original function are 3x plus 1 and x minus 4. So, we can multiply the two to get one large factor of the function and use it to find the final factor. We know that the final factor will be a linear function since the original function is cubic. The final factor will ultimately be 5x minus 2, which will multiply with the previous factors to get the original function. Hence, our final a and b values will be negative 61
If you found this video helpful,
and 2
please feel
respectively.
free to see some of our other content explaining IB Math or physics.
5 exam-style questions on functions and equations for IB Math.